we've got our orbital notation that we drew for iron with 26 electrons. If we want to write the electron configuration notation, all we're going to do is name the subshell. So remember, that's a subshell, that's a subshell, that's a subshell. You get the picture. So for 26 electrons, we're going to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, how many? 6. Be careful. Do not say that this is 1s squared. It's not. It's 1s2. Means that there are 2 electrons on the 1s subshell. You writing this down? Okay. A note about these crossovers, because we know that 4s fills before 3d. There are 2 schools of thought when it comes to this. One is that in the electron configuration, you write it in the order it fills. The other is that you may write it in the order it fills, but then you flip them and your final copy should have main energy level 3 altogether. I'm just going to go ahead and have you write them in the order they fill and not worry about rearranging. If somebody later in your chemistry career demands that you rearrange, I think that's an adjustment that you can make pretty easily. Okay, so let's practice some of these. Let's do one with 14 electrons. So this is iron, 26 electrons. 14 electrons, what would that be? You need a periodic table? I've got official periodic tables for you. Silicon, yeah. 14 electrons, Si. So, where do we start? Well, as always, with 1s. 1s2, 2s2, 2p6. What does that get us up to? Okay. Okay. Then let's finish this one and then we're going to break it down. So this gets us up to 10 electrons. What we're saying is that on the 1s subshell there are 2. On the 2s subshell there are 2. On the 2p subshell there are 6. So we need 4 more electrons. What's going to fill after 2p? 3s. How many can the 3s subshell hold? 2. So that'll be full. We're now up to 12. We need 14 electrons. What's our next subshell to start taking electrons? 3p. So we're going to have how many on 3p? 2. Okay. So let's take a step back. If you're experiencing confusion, do you understand the orbital notation? We draw the individual orbitals. Okay. All we're doing is writing down the name of the entire subshell. Now, when you first start doing these, for a lot of people, they still have to do the orbital notation to figure it out. That's okay. You'll get smoother at it. This is a shortcut from doing orbital notation. If you have to keep doing the orbital notation and then doing this, it's not much of a shortcut. But initially, when you learn it, for most people, they still have to go through and write the orbitals, and that's fine. Let's practice a couple more. Wait. Time out. Okay.
Why does 3D only have 1 and the rest of them 2?
Why does 3D1 only have 2?
And
So
the rest
we...
of 3D only have 1.
Okay. So we got up to here, and we had 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Whoops. 22?
Yeah.
22. We had
No.
20. I'm good at yet. We had 20 electrons at this point. We need 6 more electrons onto orbitals. So there's a rule, and it doesn't matter which rule it is. I think it's Hund's. Is it Hund's? That no orbital that's got the same energy, no 2 orbitals that have the same energy, neither of them is going to get 2 before each of them has 1. So this is the whole dorm room thing. You show up on the second floor dorm room. There are 3 dorm rooms on the same level. 2 of them already have somebody in there. You're not going to take a roommate until you have to. So you're going to go to the empty room first before you room up with anybody. Okay?
So you just stretch them out at the end.
So when we're filling any subshell, let's go back and do that. So we've got 6 electrons to assign. We're going to put 1 in every orbital before we put 2 in any. So 1, 2, 3, 4, 5. Then we start doubling. That makes sense? Okay. All right. Pick a number between 15 and 30.
18.
18. Okay. So let's do something with 18 electrons. What would that be? Oh.
Argon.
Good, good, good. Couldn't have picked any better. Okay, so how many of you feel like you need to do the orbitals first for right now? Okay, let's do this one and do the orbitals first and then translate. That's okay. So this is argon. So we have the 1s orbital, 2s, 2px, 2py, 2pz. What fills after 2p? What fills after 2p? 3s. What fills after 3s? 3p. Okay. It's a good start. So 1, 2. And we do these together because this is the only orbital of that energy. 1, 2. Same thing. 2s is the only orbital with that amount of energy. Now we have this whole subshell to fill. 1, 2, 3, 4, 5, 6. So now we're up to 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18. We just filled the 3p. Now if we're going to write this in electron configuration notation, go ahead and write it in electron configuration notation. I'll do it at the board and then you can check yourself. Okay. Do you want to practice a couple with electron configuration notation? Or do you feel pretty good with this?
No, we can go practice.
Okay. So, on your own, on your paper, do the electron configuration notation for an atom containing 17 electrons and 23 electrons. So 17 electrons, 23 electrons. Go.